Machine learning and artificial intelligence present great opportunities for users of digital cultural heritage. It can help researchers, educators, and general users to get a better understanding of cultural heritage. At the Europeana Foundation, we're investigating these opportunities, and we're already making use of some of them. Potentially, the use of machine learning and AI can support us in our mission to transform the world with culture. But we are cautious. The technical promises of machine learning and AI are not without risks. There are many questions around ethics, privacy, or transparency of using these technologies. In this video, we will explain how we use AI in the Europeana service infrastructure, the key policy and legal questions that we have addressed, and present several of the questions that we are asking ourselves and others to determine if and how we can use these technologies in a good way. Because we do not want to facilitate reuse of digital cultural heritage at the expense of other collective interests. We would also like to hear your thoughts and opinions. Those would allow us to make better informed decisions on the use of machine learning and AI.
Hi, my name is Jose and I'm a machine learning engineer at Europeana. And in this talk, I will present some AI work at Europeana, presenting some use cases, as well as some recommendations and best practices. So what are our goals regarding machine learning at Europeana? What are our objectives? So the first objective is enrichment, meaning the contextualization of content of metadata and augmenting the existing metadata, and data curation and quality. So ensuring that there is high quality in both content and the metadata. And for this, we have several lines of work, which I will present next one by one. The first one is enhancing image resolution. So many thumbnails at Europeana, many images have very low resolution, and this can harm reusability and user experience. The solution for this is several models that are available out there, which synthetically improve the quality of the images by doubling the resolution, and it works quite well. So we are implementing it in production. The second project is the detection of watermarks in images. Many providers and aggregators add a certain stamp or watermark at a certain location of the image, and we would like to at least flag those images so we can perhaps remove them or think what to do with them. And in order to do this, we are building a model that we are training ourselves with a data set that we are assembling ourselves for detecting watermarks, and it's working quite well. The next use case is the detection of duplicate images, which spans a little bit more of a wider case of dataset curation. And the problem is that sometimes the same images or similar content from same or different collections are present in our datasets. We don't really like this, or at least we would like to be aware of it and be able to measure it, because this can harm the user experience. And the solution for this is using basically a pre-trained deep learning model, which can already have very rich representations of images and allows us to compute similarity between images so that we can build recommendations, duplicate detection, visualization, clustering, and so on. And the last use case that I will present is related to NLP, and in particular using ChatGPT to solve a range of problems that we have encountered with minimal effort. So as you know, ChatGPT is a large language model that has been pre-trained already, and then you can interact with it in form of text, right? So then you can ask off of the chat to ChatGPT just to solve certain problems. You can provide descriptions and certain examples, and then you can get the response even in a machine readable format. So we are currently experimenting with it, and it's working quite well. And the second half of this talk is about what do we do to mitigate bias. So certain best practices and recommendations. So I will go one by one. First of all, use documentation. So recording and documenting the process of building the dataset or model, not only the content of this dataset, but also the intended use cases. And the objective of this is to improve the data provenance, transparency, accountability, and facilitate reproducibility of machine learning research and applications. The advantages of doing this is twofold. One for creators, so that they are encouraged to reflect on the process of why and how they built the dataset, and also for consumers, so that they can make sure that they're using the dataset that they are supposed to be using, or the model. The second best practice or process that we like to adopt is dataset curation. So we know that in data-driven projects, data and the quality of data is everything. So we are investing some efforts on curating and being able to visualize very large data sets and manually or semi-automatically curating those data sets in order to improve the quality of our collections and of our data sets as well. And as I mentioned before, duplicate detection will fall into this range. Another thing that we would like to remark is to make sure that when you are training a model or evaluating a model, follow certain guidelines in order to make the comparison between different options fair, right? So very basic things, but avoiding data leakage. So make sure that the training data is not in the training and test set. Also keeping the statistical distribution of the data in the training and testing data, although it depends on the imbalance, but in general this is about the best practice. And also making sure that, well, if one wants to really compare the statistical significance between models, uses something like cross-validation, so that you repeat the experiment for different splits and average the metrics. And another thing that we believe is important, mainly with deep learning, is model explainability. So machine learning models, and in particular deep learning, are considered as black boxes. So they are complex models, and there is not an easy way to know why the model is making such decisions. And in order to solve this problem, there is a branch of machine learning called explainable or interpretable AI, which allows us to interpret the decision of the models and the output of the models. We have applied this to the watermark detection problems to make sure that actually the model is looking at the watermark, and indeed one can see in the heat maps of the activation functions of the model that the highest contributing pixels are around the area, indeed, where the watermark is. So we make sure that the model is behaving as it should. So in summary, AI and machine learning is helping us a lot to deliver value to our business problems. In particular, improving the quality of our collections, curating content that might not be suitable for certain use cases, detecting data saturation, and metadata enrichment. Okay, thank you for your attention.
Hello, my name is Ariadna Matas, and I work at the Europeana Foundation as a policy advisor. So at the Europeana Foundation, we have been looking at the policy and legal side of AI in relation to digital cultural heritage. And we have paid attention to two key questions. Amongst the collections available via the Europeana service infrastructure, what can we use as input? And then the second question, to what extent can the output, if there is an output, be shared and reused? I will share our current thoughts with regards to these two questions, and they are based on the assumption that the use of the work necessary to conduct machine learning is copyright relevant, just to be on the safe side, but knowing that this in itself is a big discussion. So most of the data on the Europeana website consists of digital objects and of metadata. So on the first question, on what can be used as input, for metadata, the answer is relatively simple. Most metadata is not subject to copyright protection in the first place. And even if it was, all metadata available on Europeana is subject to CC0, so it can be used to train an AI model without restrictions or conditions. For digital objects, more questions arise. They might be protected by copyright, and we don't really know to what extent that is the case, other than what the right statement assigned to every digital object suggests. So just a quick note on that: to make data available in the Europeana website, data providers choose a right statement or a Creative Commons license or tool for every digital object made available. And this guides the use by anyone coming into Europeana, but also by ourselves in activities necessary to run the Europeana service infrastructure. So while some digital objects are marked as being in the public domain, others are subject to copyright or other types of restrictions. In this case, just below the image, you see that this document is marked as being in copyright using the in copyright right statement. We have looked at the various right statements by the Right Statements Consortium, as well as Creative Commons tools and licenses that we rely on, and following the guidance by Creative Commons, our understanding is that there is no problem in using material that is subject to any of the CC licenses or tools as input to train an AI model in our context. So the guidance by Creative Commons reads that the non-commercial restriction is the CC license element most likely to affect the activity. The other license elements are implicated when the copyright work or an adaptation of it is shared. We're mostly talking about the use of data as input in this first instance. So that is not the case for us. Plus, we consider our activities to be conducted for non-commercial purposes. So none of the licenses stop us from using the material in question in machine learning. There are situations in which we might share the results of AI efforts. For example, an image that has been enhanced, or a transcription or subtitle of a digital object. We do not consider any of these outputs to be subject to copyright protection when this transcription, subtitle, enhancement is AI generated. So none of the license conditions limit these activities either, in line with the guidance provided by Creative Commons. Unfortunately, a lot of the digital objects that we give access to via the Europeana service infrastructure are subject to right statements whose conditions do not enable this type of activities. So they are not as permissive as Creative Commons licenses and tools. And in particular, audiovisual materials available on Europeana are very often marked as being in copyright. So if we base our use for our machine learning efforts purely on the terms of a license or a right statement, there's lots of materials whose discoverability, accessibility, we would not be able to improve from amongst what's available via the Europeana service infrastructure. So in that sense, luckily, there are exceptions to copyright that make it possible for us to make use of copyright protected content in the context of data mining. This includes content that is marked with a right statement that does not allow any reuse. These exceptions to copyright are contemplated in Articles 3 and 4 of the Copyright in the Digital Single Market Directive, which is now transposed to almost all EU member states. And these two articles make it possible, first of all, for research organizations to make copies and extract information for research purposes without having to ask the rights holders for permission. And secondly, beyond research organizations, individuals and organizations can do that too, unless rights holders have reserved their rights. So because Europeana is not a research organization in the sense of the directive, we rely on the second exception, which brings up the opt-out option by rights holders. And in this regard, we really welcome the statement by Creative Commons clarifying that a CC license should not be understood as the tool to exercise an opt-out by a rights holder. While we believe that this opt-out can be a very pertinent measure for artists and certain rights holders, in our context, our efforts in AI seek to support the discoverability and accessibility of digital cultural heritage. So we really believe that something of this nature that does not create any particular harm should really be possible legally. And then beyond using copyright protected and copyright free data as input, we have also been looking at how to approach the output resulting from AI efforts. Most of the outputs in our context consist of an enhancement of an image and then also outputting little pieces of information or metadata such as information about the color of a digital object, a location, or a name. So there's only a few situations in which we might output information from the digital object that is subject to copyright protection because it was as part of that object. For example, we transcribe handwritten letters, we subtitle a video's audio, and we might translate some of this content too. Because these efforts are likely to generate lots of data in the coming years in the context of digital cultural heritage, we have recently published a policy that establishes a set of principles that will hopefully ensure consistency over time and sustainability in the reuse possibilities of machine-generated data. So among other things, in this policy, we make a commitment on how to treat AI-generated enrichments through a principle that reads as follows. No new or additional copyright or related rights exist in most enrichments, regardless of whether they are machine or human-generated. If they do exist, they are waived for the purpose of facilitating the functioning and reuse of data in the data space. This does not affect pre-existing rights in data being used, for example, a poem that is transcribed. Establishing such a principle is really crucial for us if we want to continue to facilitate the use of data from and in relation to cultural heritage. So this policy also brings up various questions in other areas, for example, in relation to data quality, transparency, and sustainability of AI efforts. For example, it makes the case for authoritative data provided by a cultural heritage institution to be differentiated from human or AI-generated data that is contributed in a separate channel, and for making available detailed information about the purpose, actors, processes, workflows for producing and validating the quality of enrichments. So this is a quick overview of some of the policy and legal questions that we have looked into so far. And we would really love to understand what some of you believe we should maybe be paying attention to and learn from your experience if you have gone through a similar process or a similar assessment. Thank you very much.
As you have seen in this video, there are several technical, legal, and ethical questions that need to be answered before we can confidently make a decision about the use of machine learning and AI. To highlight 3 of the questions. First, what level of detail and transparency is needed to inform providers and users of digital cultural heritage objects when these technologies have been used to enrich or alter these objects? And second, thinking beyond legal compliance, how can we ensure that our practices are as ethical as possible? What risk for bias in the underlying data should we be paying attention to? And third and finally, do we have a responsibility in recommending or inviting users to refrain from certain uses of digital cultural heritage in the context of AI? We would really appreciate your thoughts on this. You can let us know by participating in the survey that we have published for this conference, or by reaching out to any of us for a chat. Thank you for your time, and we're looking forward to continuing this conversation with you.